Today we're going to be converting with customary measurement using time. It's important to remember that when we're going from a smaller unit of measure to a larger unit of measure, we divide. When we go from a larger unit of measure to a smaller unit of measure, we multiply. So we're going to work with a few examples. You can see that there are customary units of time conversions. 1 year equals 365 days, and then 1 week is 7 days, 1 minute is 60 seconds. We're going to use that chart to help us. So we're going to complete the 3 examples on the left first, and we'll start with example 1. It says that the race took Daryl 2 minutes and 43 seconds. The same race took Ian 170 seconds. Who was faster? So my recommendation would be to write Daryl, and then next to his name 2 minutes and 43 seconds. Then it took Ian 170 seconds. Well, right now we have 2 different units of measure. So we're going to have to turn one of those measurements into the other. Because Daryl has 2 minutes and then 43 seconds, and Ian's measurement is already in seconds, I would recommend turning Daryl's time into seconds only. We can make a tiny T-chart. We can have minutes on the left and seconds on the right. I know that 1 minute is equal to 60 seconds, so 2 minutes will be equal to 120 seconds. Once I know that, I can take 120 seconds and I can add the 43 seconds, and when I add those 2 together, it comes out to 163 seconds. Now I know that Daryl ran the race in 163 seconds, and Ian ran the race in 170 seconds. So when the question asks me who was faster, I know that Daryl was faster because they ran the same distance and it only took Daryl 163 seconds. So I can write Daryl was faster at 163 seconds. I can complete example 2 in much the same way. When I look at example 2, it says, Mel estimated the journey would take 50 hours. It ended up taking 2 days and 5 hours. Did the journey take longer or shorter than she estimated? And by how much? So, I'm going to do the same thing. I'm going to put estimated time, and the estimated time was 50 hours. The actual time was 2 days and 5 hours. Well, I can't compare those. I need to find a common unit of time. So, because I have the estimated time in hours and the actual time in days and hours, I'm actually going to convert the days into hours for the actual time. So I can make another tiny T-chart. I can have days on the left, hours on the right. I know that 1 day is 24 hours, So 2 days will be 48 hours. So now I can take the 48 hours representing the 2 days, and I can add the other 5 hours, and that gives me a total of 53 hours for the actual time it took. Well, when I look at the estimated time of 50 hours and the actual time of 53 hours, I can see that the journey took 3 hours longer than estimated. So I can write the journey took 3 hours longer than estimated. Which leads me now to example 3. So when we look at example 3, the question says, Grace stayed at the beach for 32 days. Peter was there for 4 weeks and 6 days. Who was there longer and for how many days? Well, I'm going to do the same thing I did before, and I'm going to write Grace 32 days. And then I can write Peter 4 weeks, 6 days. Once again, it becomes difficult to compare the time because Grace's time is in 32 days and Peter has weeks and days. Because Peter also has days, I'm going to go ahead and convert the weeks into days. So I can make another tiny T-chart and I can do weeks and days. I know that 1 week is equivalent to 7 days. So 2 weeks will be 14 days. 3 weeks will be 21 days. And 4 weeks will be 28 days. So I have a pattern of multiplying the weeks by 7. So 4 weeks times 7 days is 28 days. So I'm going to take the 4 weeks, which is now 28 days, and I'm going to add the 6 days. And that tells me that Peter stayed at the beach for 34 days. So when the question asks me who was there longer and for how many days, I can already tell that Peter was at the beach longer and he was there for 2 days longer than Grace was. So I can write Peter stayed at the beach for 2 days longer. Let's practice with one more problem. If Elizabeth works on her homework for 360 minutes weekly, so I see that Elizabeth works on her homework for 360 minutes weekly. How many hours did she work? How many hours did she work? And then I see that 1 hour equals 60 minutes. So I see that Elizabeth worked on her homework for 360 minutes. And it's asking me how many hours she worked for. So 360 minutes equals some amount of hours. I can make another T-chart. And I can put hours on the left and minutes on the right. I know that 1 hour is 60 minutes. So 2 hours is going to be 120 minutes because 2 times 60 is 120. 3 hours will be 180 minutes. 4 hours will be 240 minutes. 5 hours will be 300 minutes. And then 6 hours will be 360 minutes because 6 times 60 is 360. So now I know that 360 minutes will be the same as 6 hours. Another way that I could have solved this problem is if I know that 1 hour is 60 minutes, and I know that to get from a smaller unit of measure to a larger unit of measure, I must divide, I could say 360 minutes divided by 60 minutes is going to be 6, because 6 times 60 is 360. So 360 minutes, once again, is 6 hours.